All right, welcome back. It's Mr. S here again. This is part 2 of your 5.1. Okay. Last time we looked at this Pythagorean theorem by dividing each term in that list by sine square. So if you divide by sine square, you'll get cotangent square plus 1 equals cosecant square. So that's when you divide by sine square. I didn't put the angle here, so it should be angle x. Okay, now if you divide it by cosine square, so if you divide this guy by cosine square, obviously you'll get 1 plus, if you put cosine under a sine, so sine square over cosine square is tangent square. So you got that. And then if you put cosine here, 1 divided by cosine is secant square. And then we look at how we translate them into different forms. So we can subtract 1 on this side, or even if you take 1 and keep the 1 here, you can say that if I take secant, hold on, okay? So 1 equals secant square of a x. So if you keep your 1 here and subtract tangent this way, so now you got 1 equals tangent square subtracted from secant square. And again, we repeated this formula before. So if you have one term square, which is a square minus your b square, you can always factor that if you have a minus. Okay, so 1 plus 1 minus, so secant, tangent, it goes that way. So at any time you see a problem on your math or in your math homework, if you see secant square minus tangent square, that equals 1 automatically. And then if you see cosine square plus sine square, that's 1. This is the most useful items. So if you can simplify your work down to this form right here, to cosine square plus sine square, that equals to 1. Okay? You can pause, rewind anytime you want if you missed any part of my presentation so far. Okay, moving on. There are 3 ways to write your Pythagorean theorem. Let me go back to where we came from in the last video. So those are your 3 ways to write Pythagorean theorem in trigonometry. One way, sine square plus cosine square equals to 1. 1 plus tangent square equals secant square. That's your second form. 1 plus cotangent square equals secant square is your third form. Now all of these here, you can manipulate them, you can change them around, factor them if there's a minus in between them. Namely, if you subtract this guy here, if you minus cosine, then you can factor them out into 2 parts. Okay, all right, so let's move on to the bigger things. All right, odds and even stuff. So the term odd and even, this is what I understand, okay? So if you look at this here, if you have a negative number and then you went with the even exponent, you're always going to get a positive outcome. So that means you can just look at 2 to the 4th being the same as negative 2 to the 4th power, because the exponent, it's even. You got even number of negative numbers to multiply, so that should be positive 16 in either case. Okay? So that means you can ignore the negative. So if you see an even exponent or the word even in this form, this is how I'm going to relate my lessons to the odds and even term in trig. Okay, so even, forget the negative. Odd, for example, here. The odd number, say if you have negative 2 to the 3rd, it's the same thing as having negative 2 and run it all to the 3rd power. So these 2 terms are the same answer. You got a negative on the outside and then you just run a 2 to the 3rd power is 8. Or you can multiply negative 2 3 times, it will be negative, and then you're 8 because 2 times 2 times 2. Okay, so odd, you can move the negative from the inside the parentheses, move it outside. Even, ignore it. Okay, so how is that going to work into a trigonometry? Sine is odd function. So the sine is odd function. So let me see. Cosine is even function. I need a different page. Now, if I see a sine, sine is odd function. Remember the odd function, if you have a negative, you can put the negative on the outside. So let's say sine of negative 30 degrees. You can think of it as negative on the outside and then sine of 30 degrees. Okay? So now sine of 30 degrees, how much is sine of 30 degrees? That should be 1/2. And then your negative comes around, it's negative 1/2. Now look at your unit circle. Your 30 degrees over here. A negative 30 degrees this way. So this is negative 30 degrees. Okay? So sine of negative 30 is this way. So that's negative 1/2 coming down. Now, if you ignore this negative, not ignoring, but if you think of it as a positive, it should be this number right here. Your angle should be in positive number, or your length is positive 1/2. But then this is your positive 1/2. Because you remove the negative. You put the negative on the outside, then you throw the negative on the outside. So now it looks like negative 1/2. Now, does that really matter? Yes, okay? Because in this problem here, if you see something like this, you would have to move this outside so that it becomes a minus sine term, not sine of negative angle terms. All right? Try another one. Sine of negative pi over 4 is the same as negative sine of pi over 4. So that's that. Okay, so let's say if you have sine over 4 in front of this guy, and then you got a plus. So now you notice that you have sine pi over 4 in both. Now if you take this negative and move it out here, you get the negative of sine pi over 4. This here, I just made a new problem. So you got sine of pi over 4 here. So you got sine of pi over 4 minus sine of pi over 4. The answer is 0. So we're going to play this kind of game in this unit, in this chapter. All right, so if the problem comes in like this, and it says, well, simplify this. Notice there's a minus right here. Take this minus out here. So now you look at this problem in terms of sine pi over 4 minus sine of pi over 4. The answer is 0. Okay? All right, so let's look at the even function. The even function, so let me write that here. I hope you can see. Even function is the cosine function. So for example, if I have cosine of negative pi over 6. Now, remember the word even, just like even exponent? It's kind of taking out your negative. The negative in the even exponent doesn't really matter. So this is the same as or equals to cosine of your pi over 6. Like that. Okay? I'll give you an example. So if I have 2 cosine, So if I have 2 cosine of pi over random angle, so over 3, plus cosine of negative pi over 3. Okay, that's not related to that one. This is a new example. So if I look at this, I go, okay, how can I simplify it? Well, these two angles are not the same, but knowing my cosine is even, this does not matter. So you can make that disappear. So now, are these the same angle? Yes. So you can add 2 cosine plus 1 cosine of the same angle. that answer should be 3 cosine of that same angle. It has to be the same angle to add, okay? So that's gonna be the routine for your odds and even angles. Nobody's gonna tell you when it's odd or even. You have to know that, you have to know it by itself. You have to notice, is it a sine or cosine? Sine is odd, cosine is even, if there's a negative inside. If there's no negative in it, there's no need to talk about it. Don't pay attention to it, okay? All right, so I think that's the same page. Now this is a co-function stuff, okay? So the co-function, notice cosine, so that's why there's a co-function. So the sine has a co-function, which is a cosine, all right? Secant has a co-function, it's cosecant. Tangent right here has a co-function, cotangent. So now they go backward. What happens there is, this is the two functions that added up to 90 degrees. So I made a little chart right here on the side. So I didn't write that in there. So let me see, let me show you what's going on. So this is pi over 2. It's like 90 degrees. So this angle is your theta, all right? So this here theta, if you subtract from 90 degrees, it will get you the leftover, which is angle, this angle right here. This is pi over 2 minus a theta. So now what happened here is, this is the sine of this theta, which is the height or the opposite of this angle theta. Now, if you look at this guy right here, this is the cosine on this side. So this is cosine of your pi over 2 minus theta, because this side is adjacent to this angle. This angle happens to be pi over 2 minus theta. So it's the same length. So your sine theta equals cosine of pi over 2 minus a theta. It's the same height from different way of looking at the angles. So you might want to think of that turning this way. All right, this is your cosine right here. Sine is this length. So this length right here is a sine of this angle, which is your pi over 2 minus your theta. So this length, sine of pi over 2 minus theta, equals this length, which is cosine of theta. So cosine of theta is the same as sine of pi over 2 minus theta. So they go back and forth like that. Okay, if you look at all that, you want to take a snapshot of that one, you can. Okay, screenshot the video. Okay, moving on. So this is the easy stuff. Now it relates to other functions because these are pretty much the same ratios or different ratios from having different angles on top, different sides on top of your hypotenuse on top of your sides. All right. You can review this unit, this part here. Wow, I'm at 13 minutes. I can't upload this thing too much. So, all right, so in the next video, I'm gonna do more homework right here. So how about this? You guys try the homework out, okay? Try a couple of those. I'm gonna do some of these homework questions for you in the next video. All right, I'm out. I'm at 13 minutes and some. All right, goodbye.